Good morning, Nerd Fam, and welcome to St. Louis, Missouri. We're here kicking off day one of Supercomputing. Very excited to be bringing you 3 days of live coverage on theCUBE. My name is Savannah Peterson, joined by my co-pilot in this hardware rocket ship this week,
Hey,
Dave
let's
Vellante.
go. Let's go to the moon.
I'm ready.
All right.
Yeah, I'm down. That would be fun. That would be quite the
Or
field
Mars.
trip. Yeah. One of those we're a little more likely to come back from at this particular juncture. Broadcast from the moon would be pretty sweet, though. I'm pumped about this. Are you excited for today?
I'm excited for this week.
Yes, it's going to be an absolutely fantastic week. I'm excited to see a familiar face on the desk. Avi, welcome back to the show.
Thank you, Savannah. Thank you, Dave.
And you brought a new friend, Isaiah. Isaiah, thank you so much for taking the time
Thanks for having
today. So let's talk a little bit about what's happened in the last year since you and I last spoke, just to catch up a little bit. Tell me everything that's been going on at Solidigm. Lots of action. You were smiling. Tell me demand is high. Give us the lay of the land.
Oh, yeah, storage, I think last year when I spoke to you guys, GPU and HBM were kind of the, favorite childs. And over the last year, we've seen storage kind of put itself in its place, where you've seen usages and certain solutions which have exposed the need for having high performing, reliant, scalable, high dense storage solutions. And that's exactly what we've been doing at Solidigm.
That's your sweet spot. It's almost like you do that.
Correct. And two trends have emerged. Obviously, there's when it comes to storage, you need low latency, fast, super performing storage, and then on the other end, you need high dense, cost effective storage solutions. So earlier this year at GTC, Solidigm launched our first world's first liquid-cooled SSD for storage.
And it's even in the purple branding. I love that.
Oh yeah, it's liquid-cool, where the cold plate comes and touches our SSD, and we have internal mechanism where the front and the back side cool itself, and as a result, now achieving fanless AI servers possible. And last year I talked about our world's highest density SSD.
How
Guess
many
what?
little magic tricks and fun things are going to fly out of your pockets right now? Because I'm curious.
So we are in HVM on this product. We launched, I think, just about Supercompute last year, and we're scaling. It's one of our hottest products this year. And guess what? We're not stopping. We are doubling this. Making 256 terabyte SSDs going in next year. So a lot happening in the storage world for us at Solidigm. And we're excited to work with WEKA to bring all of this storage goodness to our customers in an easy, scalable solution way.
It's remarkable when you think about the progress that this industry has made. I mean, that used to
Can
be...
we see them? Will you pass them?
Oh, yeah.
Be just
Oh,
racks,
okay.
racks and racks and racks and refrigerator sized. I mean, this is just unbelievable.
Dave, how
It's
big-
tiny.
was your
That's what
first
I was
hard
trying
drive?
to show. It's tiny. This is tiny.
5 meg. Yeah.
Exactly.
Yeah.
Exactly.
Right, this is
This is like smaller than a cell phone.
And so-
I mean, just, yeah.
Well, again, for all the...
go ahead.
Oh, please. Abby.
Oh no, I started working in SSDs maybe 20 years ago, and my first SSD was a Intel X25, a 16 gigabyte, SLC SATA 2 SSD. This right there is a 122 terabyte PCIe Gen 5
honestly, I cannot
full
believe what's
saturated
happened.
solution. So
It's astounding. For all the heat
So
this industry
light.
gets, every year we produce
that a pun?
stuff that just, no pun intended. We lower the cost per bit, we lower the cost of computing, and it's just remarkable. And it's technically quite a challenge because you got to feed the GPUs.
Yeah.
You've got to have data. It's got to be balanced. I heard Satya Nadella talking the other day about, look, the magic of the software is sometimes you need low latency, sometimes you need fast performance from the LLMs, and you got to feed these agents. So there's a balanced approach as well, but you have to feed these GPUs, don't you, Isaiah?
Well, you do, and so if you sort of just take a step back and look at the catch-up so processors have gotten faster, but they've also gotten more cores, which means that the clock rate per core is smaller, so if you could run out of clock on one core, so you need to be able to use all of them. PCI buses have caught up, but the networking world has caught up in the last 5 years. They've done like a 15-year jump forward, and now with high performance NVMe drives, now things are balanced. And when they're balanced, now you can actually feed them. So what do you need to do? You have to do some special things. So like, Avi, the indirection unit on those drives is, or what?
16K.
16K, right? So essentially what's the block size, the native block size of the page on the drive? And that means that you need to be, particularly if you want to keep durability high, you want to be nice to the drive. And that does require smarts in the software, and you need to intelligently place the data in the right spot. And so we started working together on QLC like November 2023. So we've been working a long time together. They were the first QLC drives that we actually had in our hands, and we could start to work on, okay, well, how do we make this work? And this morning we announced improvements for WEKA customers that they can get 90% with QLC. They can get 90% of the performance, but at a massive reduction.
That's the point about
cost.
QLC.
Right.
I mean, explain that to people. I mean, you're talking about what's the relative cost advantage? In QLC?
So I mean, in many cases it could be 50% cost reduction, but this is on balance when you sort of factor in everything from floor tile power up. But also, you need to be able to keep the GPUs busy. So what do you need in order to do that? You need very, very low latency. Do you need it for everything? No, but you do need it for some things, because in the process for feeding the GPU, if you have something special, and this sort of, I guess, a teaser for a future conversation with WEKA that you're having later this week, you need to be able to sort of trick the GPU into taking information during that prefill phase, particularly for inference at scale. And if you have like a model serving service, you need to be able to evict the old model and load the new model, and that all has to be transparent to the customer, and it has to happen really fast so that the time to first byte is within reasonable expectations.
Interesting. So the tricks we used to do was we'd wait for the platter to spin,
right.
we'd do other
Geometry
stuff.
tricks.
That's completely changed thanks to Flash, hasn't it?
It has, but some of the same challenges exist in the sense that, like, what's your bottleneck? So in the GPU, the memory.
I was just going to
is
ask you about the bottlenecks. We're in a really interesting,
and that's where the NVMe stuff comes in, right? So, I think you were going to say.
Yeah, we're on the same page, Isaiah. Don't worry, we're definitely reading from the same book. But I think we were talking about the evolution of the show over the last few years, and it used to be such a heavy GPU conversation. Then there's kind of been this cooling going in, and now we're in this moment where it's what are people doing at scale? How are they achieving their AI goals? What is their challenges with inference? And so I'm curious, when you're navigating this with your customers, which are some of the largest companies in the world, how are you navigating the GPU bottleneck? How are you prioritizing your solution building, I guess is what I'm asking, because you've got a lot of complexity.
Do you want to do it first?
Yeah, sure. I'll give you a view from a pure storage-centric standpoint, and maybe you can talk about this solution aspect. So for us, Savannah, it comes down to four things, whether it is inference or training. Every SSD out there, every memory designer, you want the lowest latency, the highest bandwidth, the highest density, and at a lower cost. If I give it,
they want it all. Everybody wants it all.
If I give Isaiah an option, he wants like a terabyte density at DRAM-like performance and hard drive-like cost, right?
He's so needy.
Demanding.
Right. So what do you want to trade off?
It's a question of trade-offs.
That's right.
And that's where when we see our customers adopt our storage solutions at the core data center where training's happening, you have enough power, you have enough room to scale up. There they want kind of the best-in-class performance, the Gen 5 lowest latency SSDs. But when it comes to inference, and a customer adoption is all varied. The inference data center could be in your back office, could be in your garage, could
be on your phone.
Could be anywhere, right?
Yeah.
And depending on our customers, whether they want more users to adopt this, the need for high density storage comes in. They want scalable solutions. We have certain customers where have deployed AI data centers in remote locations, which is not even accessible. They go once in 6 months, swap the drives, come back. So for them, you need high density. So from that standpoint, we have a full portfolio of storage solutions. So depending on our customer needs, they pick the flavor and then the right software to go along with it. So
you have this stair step up thing that happens where, like, just for the sake of argument, let's say that you can have, a certain number of drives in a system. If you have low density drives, then you need more computers, which amplifies the number of ports that you need, the amount of power draw, and all these sorts of things. So high density, people think, particularly for like huts and other sort of like power constrained environments, people think, oh, that's where I need them. Yeah, it's true, but you also need them just on the data center floor because you want the balance, right, of the network and the drives and stuff. And so if you have too much I/O on the inside, but you can't get it out, then that doesn't help. But now with PCIe 5 and PCIe 6 systems, you can get it out, right? Provided that you actually are, sizing everything correctly. The service provider mentality, though, and the enterprise mentality have radically different deployment models. So if I'm a service provider, I care about pods and blast radiuses and stuff like that. If I'm an enterprise, I'm just going to potentially cram it all into one giant cluster. And so the inference and training workloads look very different. What we see on the training side, if I think about like our largest training customer and what they have, like they have many clusters, but their largest cluster is just enormous. Like it's too big to fail. And there's 100,000 GPUs in front of it, and they need to get some of their clients are more important than others, the software clients. So they get single and double-digit microsecond latencies on some of these calls because that's the way that they can actually update their models. They're looking to reduce their epoch times because they want to get 11,000 updates a year out in order to have iterative product development. That is totally different from inference customers who are interested in how do I make sure that I don't lose people's attention. There was this cool like retro computing show called *Halt and Catch Fire* that talked about this thing called the Doherty Threshold.
Amazing show.
Remember the Doherty Threshold? It was like 400 milliseconds, on the echo return. Well, everything it's old is new again, and it's the same thing with your inference cases where if the amount of time it takes to load that model, load the context window, and give you time to first byte takes too long, people get bored and they move on. And so it might be a batch-oriented inference workload, in which case, who cares? But if it's on your phone, right, or hey, I want to look at what animal is this, or what bird sound is that? I have like 5 seconds or something like this, maybe less.
I would say less.
Yeah. So.
I mean, inference is what makes AI real. None of the stuff that we're talking about in terms of its real-world application and experience exists if inference isn't optimized, and people don't have that. We were talking about Grok earlier, Avi and I, and when you talk to Jonathan, inference is everything. I mean, that's the currency, right?
And it requires more data too.
Correct.
Yes.
Which means back to density. If you don't have the ability to actually handle that and give it the I/O that it needs, you're gonna feel it.
So back to those trade-offs that you were talking about, there's always the pyramid, right? Processors are going to go faster than memory, you're going to go faster than deep storage, and so you've got this sort of memory wall that you hit that you have to continuously balance. So how are you attacking that problem together?
The memory wall concept was defined in a 2024 paper.
Right.
And it essentially said that memory has become the bottleneck for GPU feeding. And they were talking about it in terms of general GPU use. I don't think they specified training versus inference. And so what we do is we extend the area of memory that the GPUs can use. So from a GPU perspective, nothing changes. It's still the same address ranges. But what we do is we are feeding at essentially memory bandwidth speeds into the prefill phase of that inference workload so that when the decode starts to happen, you're actually able to think, oh, I have this infinite amount of memory. So in practice, this means you need two things. You need the infrastructure to support it, which means the hardware and the software. But you also need to have hooks in your inference runtime, so like VLLM or TensorRT, in order to take advantage of those things. If you were paying attention to GTC, there was the Dynamo project with KV cache. Now, that is using GPU memory exclusively. What we did with Augmented Memory Grid, which is the teaser for the future CUBE session for watchers, is we extended that into storage. This was at the first GTC of the year. We announced that we had done this, and we were the reference design for it with NVIDIA.
So you're creating a virtual pool from the GPU memory to the storage layer?
You can think about it as a pool. I mean, if you want to get a little bit more alien, it's a wormhole from the GPU into storage, because you're looking through a keyhole of GPU memory into a vast universe of high performance, high density NVMe.
Sure.
So what we're really talking about here is AI economics at scale. AI economics to a degree.
Yeah.
And when we're this is why partnerships like yours are so important, because you need each other to optimize that for your customers. Outside of the inference layer, the super technical bit that we were just talking about, when your customers, because you guys co-collab on a lot, when your customers come to you, what's the number one thing they're looking for in terms of a solution? Is it that I want to do it faster, better, stronger? Is it that I want to have the best stack and tools and storage for this? Like, what are the words coming out of their mouth?
I think efficiency is one of the most important things across the spectrum, right? We talk about AI. You absolutely need to feed the GPU. Right?
Yeah.
That's the most expensive commodity in your whole data center. And anytime a GPU is idle, that's revenue lost.
Wasted money.
Wasted power consumed. And as a result, efficiency becomes key, right? We talk about performance. But guess what? When things are performing, it also gets harder. So cooling, like
quite literally, we were talking about how it's warm in here because of all the.
This is my first day at the conference, and I have not had a chance to visit all the booths, but I literally saw like 20 companies talking about cooling, immersion,
at least?
liquid. Yeah, that's just 5 minutes of me walking from the entrance here, right? And that's efficiency. Efficiency is not just about high performing, low latency. You need the entire solution to work in synergy with the networking, with the compute, with the software abstraction above it to give what our customers really want. Yeah,
that means you need to measure stuff. So, and actually, at I think it was last month or the month before, the Spec Storage Committee sort of finalized the plans for integration with Spec Power, where you can take a power analyzer, which includes your all-in power, right, all-in watts, which includes cooling, and say, all right, what's my performance per watt, right? And then once you know what your performance per watt is, you can go look at what's your I/O per watt cost, and now you can balance that with what's my I/O per watt per dollar, right? Which is the real mitigating factor for a lot of people.
And per token, right? Because that ultimately I'm producing intelligence, which I guess are almost interchangeable with tokens, right? I mean,
absolutely. The whole deal is to bring down millions of tokens, the dollar to generate millions of tokens every year, every iteration down. Right.
And in the training side, I mean, look at GPT-5, a lot of people complained about it when it was released, but it was a significant economic improvement, over the previous generations. Yeah. And then when you get to inference, it's a whole, different set of economics.
And so if you're hosting your own model, this matters even more.
Yes.
There's lots of folks out there who do use services like that, and for them it's about the cost of the API. Yes, cost per token matters, but they really have no control over, am I reusing a token, am I recalculating? So if you want to peel that layer back and take control over the economic parameters, then you need to host your own models, because that's where things like AMG and Dynamo and KV Cache and the efficiencies that high density, high performance NVMe come into play.
And I think too often storage is left out of the equation. I mean, I always call the new Jensen's law as buy more, make more, or save more. Right? That's the new sort of economics. But it's actually true if you're power constrained. If that's your constraint, and you can double or triple or quadruple your performance.
Or you just yield constrained, right?
Exactly. And then, but Jensen always emphasizes it's an entire system.
Right.
But he doesn't talk a lot about the storage piece of it. That's where you guys come in. And that balance that we've been talking about is critical. Otherwise, you're not going to be able to feed those GPUs, and you're going to blow apart the economics.
You know that old adage about special effects, that if you noticed them, they didn't do a good job?
They weren't, exactly.
I feel like storage gets relegated to that a lot.
Yeah, it does, but all the trends we are hearing...
It's a good analogy, Isaiah.
All the trends we're hearing in the AI world, synthetic data outpacing real data, the need for more inference data, all of that means there's more data. And data is like the AI data pipeline. You need to store that data effectively, reasonably well, reliably, because that matters.
In the right place.
At the right place.
Yeah.
And as a result, I feel, we at Solidigm feel we're in the right trend where we're meeting our customer demands, though demands are right now outpacing supply across the industry. It's a pretty good year going into 26.
Do you see any signs of that demand waning? Is there? I mean, I'm sure you sleep with one eye open in this business because you're moving so fast. Is there any indication that demand is not going to continue to outstrip supply for the foreseeable future?
I think we're direct attached to NVIDIA GPUs, right? The more GPUs, every GPU every B200 system out there has 8 E1.S slots, direct attach, and then to feed the GPU, you need an object store box, either from WEKA or from other suppliers.
File system, ideally.
File systems, and yeah, that continues to grow, which is a good thing.
Yeah.
That is a good thing. Well, Avi, your positive energy is contagious. I appreciate it. Yeah, I feel like you just uplifted us. I can tell from just your energy alone how good things are going from both of you. So let's take a look into the future. When we get to hang out at Supercomputing in 2026, what do you hope to be able to say then that you can't yet say today? Avi, I'm going to start with you, but then I'm
That's more than a prediction. That's what do you got cooking?
Not a prediction. I actually, next Supercompute 26, Solidigm will be there with a 256 terabyte. First time when, we talk about 122 being a hot product, we are not stopping. We're going to go push the envelope to push the density bar higher, bring the cost down for our customers so that we can give them more density at scale. So we're definitely going to do that. That's one prediction. And the second one, I feel you'll see more usages, RAG offload, KV cache, pushing a storage-centric design architecture where you are looking at storage when you're designing inference data centers or core data centers with storage in mind, with flash in mind. It has to be the case going forward.
Everybody thinks they're compute bound, and then you give them a good storage, and then they realize they weren't compute bound. All right.
I bet. Oh yeah, that is
like the wall clock comes down on jobs.
Yeah.
I think we're going to see megawatt racks in 2026.
Yeah.
Mm-hmm.
Today we have customers who are deploying almost 400 kilowatts per rack.
Yeah.
And that's with GPUs hot. When they're not hot, when they're idle, it's still like a 40 kilowatt rack. It's still a lot.
Yeah.
And I would say that like the storage as a first class citizen in AI, I think is definitely going to be a realization that people have. But it takes a couple of things, right? It takes them realizing, oh, I wasn't compute bound, and that means they need to know more about their workload.
Yeah.
And a lot of people don't. It takes people realizing that tokenomics only get better when you host it yourself.
I think that's an outstanding point. It's got to make you feel good hearing him say that, Avi. You're like, I know, we've been waiting.
Buy more drives.
Yeah.
Bigger drives.
Bigger drives.
I love it.
Buy more drives, bigger drives. And that 256 terabyte drive, PCIe 5 or PCIe 6?
5.
Okay.
Well, we look forward to
see.
confirming both of those predictions and seeing your
When you have bigger
solution.
drives, you need fewer of those.
Yeah. Yeah. It's just more efficient.
The customer doesn't think so. They just,
Yeah.
they're just like, oh, I can have more.
Give me all the things. The hardware hoarding is very real
Jevons
right now.
paradox: lower the price, they buy more.
That's right.
No?
Yeah.
Good bet.
And they're going to take on bigger problems is really what it boils down to. Nobody ever says, oh, I can save margin on my operating expenses. They just say, oh, I can do more.
No.
Right?
That's a really good point. This has been fantastic. What a beautiful way to start the show. Isaiah and Avi, thank you both so much.
Guys.
Thanks.
And thank you, Dave. Always fun. I can see you getting excited, taking notes over there. I see that little brain
Yeah, I'm
cranking away.
Save this book for 2026 and bring it back.
Yeah, so
You've done that before.
I do
predictions. That
I
was
do it
good.
every
Where
show.
do you think I got the idea?
Fancy that. I hope you're just as inspired as we've been by this starting segment here at SC25 in St. Louis, Missouri. My name is Savannah Peterson. You're watching theCUBE, the leading source for enterprise tech news.